Good morning, Chad. Your EEC-IV computer arrived. It's a LAD1. Looks like this is a speed density computer out of a 96 or 97 era truck. And I've got it hooked up to my EEC-IV basic bench tester. This is going to be power. This is check engine light, and this is fuel pump relay and 5-volt regulator. So we turn it on, we see the check engine light lights up and the fuel pump primes for 1 second, just like it should. 5-volt regulator has 5.04 volts, so that's good. And the check engine light's coming on, that's good. And then we switch it over into code pulling mode. And after the pump runs and the check engine light wigs out for a second, then it should start blinking some steady 2-digit treble codes. And it's doing that fine. So the computer is operational. It's able to think clearly. The complaint is bank 2 injectors drop out under a load. Okay. What I see here, this computer has tried to be repaired before. I don't know if that was successful or not. We'll take a little closer look later on with some better magnification, but I can see somebody's done a bridge here, and that work is probably not going to cut it. I still see looks like corrosion at the solder joints there, and that's a mess. So what happens with these capacitors, as you probably know, once they get about 20 to 25 years old, they leak, and then they drip their little acid on the board below, and it corrodes the traces on the board. And if that's not found pretty reasonably quick, you can end up doing some permanent damage to the board. So I think we need to do probably some better repair work there. And the other two look pretty good. I see some bare copper traces here, so somebody's been scratching on this board and probably did not put some new conformal coating on it when they were done, so that's going to be a future corrosion point. And that capacitor is new and been replaced. That one is new and been replaced. And that one is new and been replaced. Looks like I see a little bit of brown staining under that one, so that one's probably got some corrosion under it. That corrosion, if you don't get it all off, it continues to eat even after you replace the capacitors. So we need to remove that, neutralize the acid, clean everything really good, repair any damaged traces, and put it back together. The other thing I see is that all three of these capacitors have the same rating on it. I don't know if I can get a picture of that, but 47 microfarads, 16 volt. 47 microfarads, 16 volt. And again, 47 microfarads, 16 volt. So I think that's a problem. I don't believe that all three of these capacitors are going to have the same rating. So I don't think these were properly replaced. Also, the direction of the capacitors matters. The polarity matters. Looks like all three of these stripes are going the same way, and they're all going to the right. I'll need to find a reference computer to make sure that that is correct or matches the direction they're supposed to go. And since we don't have the capacitors, or since I wasn't the first guy to dig into these capacitors, I don't know what the ratings were supposed to be in this particular computer. So we're going to have to do some legwork and try to find out what this is supposed to look like, and then see if we can't maybe repair it. I'm not sure that the capacitors are going to affect all 4 injectors on one bank, but we can try to get to the bottom of that as well and see if we can't find a reason for that. Maybe power to one bank has been damaged by the capacitor repair. So hopefully that will be related. All we can do is dig around and see. But that's where we're at. I think that's where we're at. I think that's probably the problem. And that depending on how mucked up this particular capacitor's traces are, we'll see if we can't maybe repair that. Okay.